What I'm more interested in, or what I want to point out here, is that this is a drastic change in how security and threats in the automotive industry have been before versus will be in the future. Because if you think of who is currently interested in hacking a car, it's basically tuners and thieves. But if we contrast this to the amount of people that are driving a car, right? These are quite small number of people. And now we have these two changes. We have this technological change, as Tobias mentioned, that we are going to aggregate, centralize our functionalities in one common hardware. And this hardware is much more powerful than in the existing setup, where we have basically one small microcontroller for every single application.
It kind of means, everybody who's out there in the world doing hacking today, attacking IT systems, has experience in similar architectures and similar systems, and might now be up to also attack a vehicle computer. So that's really a really drastic change.
So there are many new attack paths that now determine if the entire system still is secure or not. And what we do is, or what we propose here, is that we actually now do something that we call cross-domain security. And the concept, if you summarize it, it is, I think, well summarized with these 4 main points. The whole idea is about creating different layers that are actionable. So the architecture that we propose is trying to create certain points where we can then create a local security response. And that is also an automated security response.
And this is specifically tailored now to the automotive scenario, let's say, because in the end, safety of our passengers is the utmost concern, right? We cannot say, okay, our system was secure, but someone got injured because of that. We need to make sure that our drivers are safe. And this need for availability in the safety systems is now properly reflected here into this segmentation concept.
If you do the segmentation like that, what you gain is the following. If you look at on-demand, QM on-demand domains, so software that can be stopped, if there is an attack in progress and you identify the attack, you can simply stop this virtual machine. And you gain this capability by the segmentation. And you have to keep in mind that identifying that there is an attack running is more likely and easier than directly understanding what is the attack path and what software pieces are actually really participating here.
The thing that we want to advocate here is to maybe think about what we already have out there in other fields maybe, and see how we can transfer this instead of reinventing the wheel.